Let us discuss one important key point, that is maximum oxidation state of an element is equal to its group number. Maximum oxidation state of an element is equal to its group number. No one element oxidation state exceed its group number. Example, phosphorus 5A. So maximum oxidation state of phosphorus plus 5. So phosphorus cannot show more than plus 5 oxidation state. Sulfur 6A group, maximum oxidation state of sulfur plus 6. And xenon 8 group, 8 group number 8, then maximum oxidation state plus 8. Okay, so maximum oxidation state of an element is equal to its group number. Okay. Among all elements, the maximum oxidation state, that is plus 8, shown by some elements. Examples, ruthenium plus 8 in RuO4 compound, osmium plus 8 in OSO4 compound, xenon plus 8 in XeO4 compound. So maximum oxidation state plus 8. So these are shown by some elements, ruthenium, osmium, xenon. Among all elements, the maximum oxidation state, that is plus 8, shown by some elements, ruthenium, osmium, xenon, plus 8 in RuO4, plus 8 in OSO4, plus 8 in XeO4. Okay, no one element can show more than plus 8, and the maximum oxidation state of an element is equal to its group number. Okay, so let us discuss some examples. H2, S2, O8. Here we have to calculate sulfur oxidation state. See, general calculation, hydrogen plus 1 plus 2 sulfurs plus 8 into minus 2. This is a neutral molecule, that's why 0. Now 2 sulfurs, minus 16 plus 2, minus 14, right side plus 14, sulfur we are getting plus 7. Is it correct? No. Why? Because sulfur maximum oxidation state plus 6, but by general calculation we are getting plus 7. That's why wrong. Then how we calculate sulfur oxidation state here? To calculate sulfur oxidation state here, we must know the structure. The structure of H2S2O8. This is the structure of H2S2O8. If you observe, 2 oxygens, peroxy linkage, we know in peroxides oxygen oxidation state minus 1. So for these 2 oxygens, oxygen oxidation state minus 1, not minus 2. In the remaining 6 oxygens, minus 2, minus 2, minus 2, minus 2. Now you calculate based on structure. 2 hydrogens, 2 into plus 1, 2 sulfurs, 2 sulfurs. In 8 oxygens, 6 oxygens only minus 2. Remaining 2 oxygens minus 1, that is equal to 0. Now plus 2 minus 2 cancel. Now 6 2s are 12, minus 12 right side plus 12, 2s plus 12, and sulfur oxidation state plus 6. This is the correct oxidation state, plus 6, but not plus 7. Like general calculation we are getting plus 7, but plus 7 not possible because sulfur maximum oxidation state is group number 6, that is plus 6, but we are getting plus 7. So how we calculate sulfur oxidation state? Based on this structure. Okay, 2 oxygens peroxy linkage, that's why 2 oxygens oxidation state minus 1, remaining 6 oxygens oxidation state minus 2. Okay, so based on this we are getting plus 6. H2S2O8. What is the name of this compound? Marshall's acid. Marshall's acid or peroxy disulfuric acid. Peroxy disulfuric acid. Sometimes directly given name, not given formula. What is the oxidation state of sulfur in Marshall's acid? +6 or peroxide disulfuric acid. Next one, H2SO5. Carous acid or peroxymonosulfuric acid. Carous acid or peroxymonosulfuric acid. Monosulfuric acid. Based on general calculation, 2 into +1 +2, 5 into -2 -10, -10 +2 -8, then sulfur oxidation state +8, but +8 not possible. Then based on structure of H2SO5, if you observe 2 oxygens again peroxyl linkage, so these 2 oxygens -1, remaining 3 oxygens -2. Now calculate 2 into +1 plus sulfur. In 5 oxygens, 3 oxygens -2, and 2 oxygens -1 is equal to 0. Then sulfur, after count, +2 -2 cancel, then +6. Sulfur +6, but +8 not. General calculation we are getting +8. +8 not possible for sulfur, because sulfur maximum oxidation state +6, because group number 6th. Okay, so H2SO5, Carous acid. In Carous acid, sulfur oxidation state +6. Peroxymonosulfuric acid, sulfur oxidation state +6. Okay, next one, H2S2O7, name oleum. What? Oleum. First general calculation, 2 into hydrogen +1, 2 sulfurs plus 7 into -2 is equal to 0. 2s is equal to -14 plus 2, -12, right side +12, then sulfur oxidation state +6. So in oleum, all 7 oxygens show -2 oxidation state. Finally sulfur we are getting +6 oxidation state. Okay, so like this you calculate some element oxidation state directly calculate based on general method, but some element oxidation state calculate based on structure. Okay, let us discuss one more example, CrO5. General calculation, Cr plus 5 into -2 is equal to 0. So Cr plus 10, we are getting +10, but no one element can show more than +8 oxidation state, but here we are getting +10, so +10 not possible. How we calculate? Based on structure. What is the structure of CrO5? CrO5. This is the structure of CrO5. If you observe this one, peroxy linkage, peroxy bond. This is also peroxy bond. So in peroxides, oxygen oxidation state -1, -1, -1, -1, -1. Here oxygen oxidation state -2. Now you calculate Cr plus 4 oxygens -1 plus 1 oxygen -2, that is equal to 0. So now Cr -4 -2, right side +6. Chromium oxidation state +6. In CrO5 chromium oxidation state +6, but not 10. Got it? So based on structure we have to calculate chromium oxidation state. Here CrO5 structure looking like butterfly structure. Okay, next one, C3 wood. What is the carbon oxidation state in C3 wood? Carbon suboxide. Okay, in this general calculation, 3 carbons, 2 oxygens -2 is equal to 0. So 3 carbons plus 4, then carbon oxidation state plus 4/3. So this is the average oxidation state of carbon. Average. Why? 3 carbons are there, so 1 carbon oxidation state plus 4/3. This is average oxidation state. For suppose sometimes asking what are the oxidation states of 3 carbons in C3O2. For doing this, we should write the structure first of all. Carbon suboxide. This is the structure of carbon suboxide. Listen, how to find each carbon oxidation state. See, this carbon connected to oxygen. We know oxygen oxidation state -2. Again this carbon connected to carbon, similar atom. So with similar atom there is no any oxidation state, 0. With similar atom oxidation state 0. Now coming to this carbon connected to oxygen, here -2. So here -2 means then this carbon oxidation state +2, because with this carbon 0, with this carbon 0, because similar atom, with this carbon 0. Now this oxygen atom -2, then this carbon +2, because as this is -2, then this carbon should be opposite charge, +2. Okay, now coming to this one, carbon oxygen oxidation state -2. Now coming this carbon connected to carbon, similar atom. So with similar atom 0. So now -2, then this carbon +2. Okay, now coming to the middle carbon. So this carbon connected to carbon, similar atom, that's why 0. This carbon similar atom 0, that's the overall oxidation state 0. So middle carbon 0, right side carbon +2, left side carbon +2. Okay, now average oxidation state. Average oxidation, how you calculate average? Total sum +2, 0, +2, number of carbon atoms 3, +4/3. This is the average oxidation state. Sometimes asking what are the oxidation states of 3 carbon atoms in the carbon suboxide? +2, 0, +2. Middle carbon 0. Left side, right side carbon +2, +2. Got it? So based on structure we have to calculate. One more. Br3O8. Br3O8. In Br3O8, what is the bromine oxidation state? Average oxidation state of bromine. See, 3 bromines plus 8 oxygens, 8 into -2 is equal to 0. Then 3 bromine, 8 -16, so +16, bromine +16/3. Average oxidation state +16/3. Average. Now we have to discuss structure of Br3O8. This is the structure of Br3O8. Now check this bromine connected to oxygen -2, oxygen -2, oxygen -2. Now connected to bromine. So with similar atom 0. Okay. Now -2, -2, -2, -6. Then this atom should be +6. +6 because -6 no opposite charge, +6. Okay. Now coming to this one, this bromine, oxygen -2, oxygen -2. Again left side similar atom, right side also similar atom, bromine. So with similar atoms 0. Now -2, -2, -4. Then bromine oxidation state +4. Now coming to this oxygen, 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 -2, -2, -2. Left side bromine similar atom. So with this bromine 0. Now -2, -2, -2, -6. Then this bromine +6. Now average oxidation state of bromine is equal to +6, +4, +6 by number of bromine atoms 3, that is equal to +16/3. Sometimes asking individual atoms, otherwise asking overall oxidation state, average oxidation state +16/3. Individual plus this bromine +6, this bromine +4, this bromine +6. So average oxidation state +16/3. So based on structure you have to calculate like this. Okay, no? So these are the some examples. Calculate oxidation number. Hope you got how to calculate oxidation number of elements. In the next class we will discuss redox reactions and the types of redox reactions. Okay, thank you.